Hello, young ladies and young gentlemen. This continues my series of YouTube lectures on applied computer science for those students who need some supplemental education to add to the restricted COVID-19 remote learning possibilities. This is part of the series. I'm doing a series of YouTube lectures on understanding what is happening on the memory chip while you're running a computer program. When you're running a computer program, you want to understand what's happening on the memory chip. As part of that, I want to talk today about immutable values and mutable values, okay? As part of understanding what is happening on the memory chip when a computer program runs. Okay, a mutable value is a value that you can modify in place without changing the location of the value on the memory chip. As it turns out, this array is an example of a mutable value. This is a value that has a location on the memory chip, and I can make a modification to it without changing its location on the memory chip. An immutable value is a value that you cannot modify in place. So any value is either this or this. So an immutable value is a value that is not a mutable value. Okay, the simplest types of values, the simplest and smallest types of values for beginner students are numbers and strings. A number is always an immutable value. So a number is always an immutable value unless you're using a programming language from the 1960s, which you are not. So you can always assume that a number is an immutable value. You cannot take the number and modify a little piece inside that number value. You cannot do that. And in general, a string is usually an immutable value as well. That depends upon what programming language you're using and what choices the designer of that programming language made. But I am assuming, in the context of my teaching, that strings are immutable values, unless I say otherwise, because with most modern programming languages that people use today, the designer of the programming language, for reasons of convenience, decided that a string would be an immutable value. Ruby is an exception. With the Ruby programming language, a string can be a mutable value. So a string is a mutable value if the designer of the programming language decided, okay, I have a string red hat, and it's at a specific location on the memory chip, and then I'm going to allow the user of my programming language to switch the letter D to the letter C. Everything else stays the same at the same location on the memory chip. I'm not changing anything on the memory chip. It's the same string, but I take one little piece, one little character, and I change it, or to change the white space to an underscore, but everything else stays in place. That is the case with the Ruby programming language, but with most programming languages in use today, the designer of the language decided that strings would be immutable values. So unless I say otherwise, that's what we're doing. Okay, so numbers are immutable values. Almost always strings are immutable values. Pretty much everything else is usually a mutable value, and let me explain why. Aside from numbers and strings, most other values are mutable values. What does that mean? Well, if I have a value that is not a number and not a string, then most likely that value is a complex value. Most likely that value is a single value. That value is one single value that has multiple pieces inside. So that value could be that this glass is a value, and if I put marbles inside the glass, then this glass is a single value that has multiple pieces inside. Most values that are more complicated than numbers and strings are like that. They're what we call complex data structures. And for beginners, when I talk about complex data structures, what I'm talking about is an array, or maybe a hash. And you'll learn about other complex data structures at a later time. So, an array is a mutable value. So if you have a value that is not a number and not a string, most likely that value is a complex value. That value is one single value with multiple pieces inside. And if you can change one of those internal pieces, therefore, that value is a mutable value. Here is an array. Okay, the array stays at the same location on the memory chip. The array is not completely destroyed, but it's a slight modification, and it's not moved. The array is not moved from one location on the memory chip. This array does not change its location on the memory chip, but I just modify one piece inside. The 8 changes to a 7. So an array is a value. An array is a complex value that has multiple pieces inside. I have the option of modifying one of those internal pieces, and therefore an array is a mutable value. Now, understanding the subtle implications of mutable values versus immutable values does require more examples. It does require some further context. And hence I have this. These are two assignment statements, one done after the other. I assign to x the value 6. After that, I assign to x the value 5. Now, 6 is a number. That means 6 is an immutable value. Okay? When you see 6 being changed to 5, you might think mutable value. No. So this is not a situation where I have a mutable value, and let me explain why. I know it's subtle. 6 is an immutable value. That means it cannot be altered in place without changing the location on the memory chip. But that's not what's happening here. I changed the value that the variable name x points to. I changed the location on the memory chip that the variable name x points to. After I do the second assignment statement, the variable x now points to a different location on the memory chip. That is a different situation. So when I talk about mutable values, first do this assignment statement, then this assignment statement. That is not what I'm talking about when I talk about mutable values. Those are two different situations. Remember, the value 5 is put at a different location on the memory chip, different from the location on the memory chip where the value 6 is. So it's a different situation. I'm simply changing where on the memory chip the variable name x points to. Now, let me take another look. Let me look at an example that's even more subtle, so pay attention, because this is subtle. Again, consider two assignment statements. This assignment statement is done after this is done. But consider it done with an older programming language. I'm thinking of C. Not Ruby, not PHP, not Python, but C or some other older programming language. With some of the older programming languages, such as C, the meaning of the concept variable name is a little bit different. With some older programming languages, the variable name x is locked into one specific location on the memory chip. It doesn't just change where it points to, just higgly-piggly. So with older programming languages, the variable name x could be locked into one location on the memory chip, and what happens is this. At the location where the value 6 is, the value 6, pay attention here, this is subtle. The value 6 is completely erased. The value 6 is not altered or modified. The value 6 is completely erased, 100% erased, as opposed to being modified. And then there is no value there. There is no value there at all. And then the new value 5 is created at that location. So I go from the value 6 to no value there at that location at all to the value 5. Again, I know this is subtle. That is not what I mean by mutable values. I don't modify the value 6. I don't take a little computer bit, the smallest unit of memory available. I don't take a little bit of memory inside the value 6 and modify it. That's not what I'm doing. I destroy the value 6. There is no value there anymore, and then I put a new value there. And when I do that, that is not the situation that I am talking about when I'm talking about mutable values. I know that's a subtle example. Now, this lecture on mutable values and immutable values is getting long. And it's hard to keep track of this, so I'm going to break up the mutable values and immutable values into 2 YouTube lectures to make it easier for me and make it easier for you. I stop there.